All right, today we're cracking open a cosmic cold case, a mystery that's been unsolved for 4.6 billion years. And the clues we're looking at, well, they aren't fingerprints or DNA. Nope, they're microscopic crystals, tiny bits of dust that are actually older than the sun itself. So let's get into it and see what story they have to tell.
For years, we all thought we knew the story of how our solar system came to be. But what if that story, the very spark that created our sun, our planet, everything, was just completely wrong? It's a question that's really shaking things up in astrophysics right now.
So, to really get why this new idea is such a big deal, we've got to go back and look at the theory everyone believed, the story that was pretty much textbook fact for more than 40 years.
The standard story is, well, it's pretty dramatic. You've got this huge, cold cloud of gas and dust just hanging out in space. Then, right next door, a giant star goes out with a bang, a massive supernova. The shockwave from that explosion slams into the cloud, giving it just the kick it needs to start collapsing on itself, and boom, the sun ignites and the planets start to form. It's a really powerful and honestly an elegant explanation.
And wow, just look at this. This is the Vela supernova remnant. I mean, you can feel the sheer power just by looking at the image. For decades, this is the kind of thing scientists thought gave birth to us, our entire world, born from the beautiful, violent chaos of a celestial fireworks show just like this one. So why was everyone so sure about this supernova story? What made it stick for so long? Well, it turns out they found what seemed to be the perfect cosmic fingerprint, the smoking gun. And here it is. This is the Allende meteorite. When this rock from space slammed into Mexico back in 1969, it was more than just a cool event. It was a time capsule, straight from the birth of our solar system. And when scientists carefully cracked it open, they found something inside that, well, it shouldn't have been there.
Okay, so to get what they found, we need a quick, painless chemistry lesson. An isotope is just a different flavor of an element, and the one we care about here is called aluminum-26. It's radioactive, which just means it's unstable, and it decays into something else over time. You can think of it like a stopwatch that was started billions of years ago.
So here's the crucial part. Supernovas are basically these giant cosmic factories that forge all sorts of rare elements, including tons of this aluminum-26. The theory goes that the explosion created it, shot it across space into our little cloud, where it got baked into the first rocks, like the Allende meteorite. Then, over billions of years, that unstable aluminum-26 slowly broke down, leaving behind its decay product, a stable isotope called magnesium-26. And that is exactly what scientists found. Way more magnesium-26 than they could otherwise explain. It was the perfect smoking gun. It seemed to prove that a supernova not only kicked things off, but also salted our early solar system with this special radioactive material. Case closed, right?
Well, not so fast. Just like in any good detective story, another piece of evidence showed up that just didn't fit the narrative. A pretty big crack started to appear in this seemingly perfect theory.
And the whole problem, the thing that started to unravel everything, came down to one simple question. A question that cast a huge shadow of doubt on the whole supernova idea. If a supernova did this, where in the world is all the iron-60?
See, here's the thing about supernovas. They're incredibly messy. They don't just cook up one special ingredient. Any supernova powerful enough to make all that aluminum-26 should have also churned out a boatload of another radioactive isotope, iron-60. So logically, our meteorite should be full of it. But when scientists went looking, they found next to nothing. The iron-60 was missing.
For a while, people tried to explain it away. The astronomer Vikram Dwarkades calls it hand-waving. You know, oh, maybe it was a weird kind of supernova, or maybe the elements just got separated somehow. But after a while, the lack of evidence became evidence itself. The story just wasn't adding up, and the scientific community started to shift. The original suspect just didn't fit the crime scene anymore.
So, if the supernova is no longer our prime suspect, then who is? Well, the investigation turned to a new and, in some ways, an even more bizarre cosmic culprit.
Take a look at this. This is the Dolphin Head Nebula, and that amazing shape isn't from an explosion, it's a gigantic bubble in space, carved out by the insanely powerful winds from a type of cosmic monster called a Wolf-Rayet star. The new theory is that maybe we weren't born from a violent bang at all. Maybe we were gently formed inside a dense, protective shell created by one of these giants.
And this is where the new theory really shines.
A Wolf-Rayet star's powerful winds are the perfect environment to create lots of that aluminum-26 we found. But, and this is the absolute key, they produce almost no iron-60. All of a sudden, everything clicks into place. This new suspect explains why we have one isotope and why we're missing the other. It's a perfect match for the evidence.
So what exactly is a Wolf-Rayet star? Well, imagine a star dozens of times bigger than our sun, burning thousands of times brighter. Its stellar winds are so intense they act like a cosmic snowplow, sweeping up all the nearby gas and dust into a thick, dense bubble. Now here's the big difference. A supernova forges heavy elements through intense pressure and heat, including lots of iron-60. A Wolf-Rayet star, though, it's a different kind of furnace. It cooks up aluminum-26 and then gently blows it outwards in its winds. It just doesn't make much iron-60. And get this, some studies suggest that as many as 1 in 6 stars like our sun might actually form inside one of these cosmic nurseries.
Okay, so the Wolf-Rayet theory is super compelling. It fits all the clues, but a great theory needs rock-solid proof. And that's what brings our whole detective story right into the modern day, to a high-tech hunt for that final definitive piece of evidence.
And that proof lies hidden inside these things, presolar grains. Now, these are literally what they sound like, tiny crystals of stardust that are older than our sun. Just let that sink in for a second. They formed around other long-dead stars, got mixed into the cloud that formed our solar system, and were then trapped inside meteorites. They are the oldest physical objects we can actually touch and study.
And just look at them. Every single one of these little specks is smaller than a bacterium. Yet each one is a messenger from the distant past, carrying the pure, unaltered chemical signature of the star that created it. They didn't get mixed up in the mess of our own solar system's formation. They are the ultimate eyewitnesses to what came before.
As you can imagine, finding them is incredibly hard. Cosmochemist Nan Liu puts it perfectly. She says this is like a fishing expedition. It's incredibly patient, painstaking work, sifting through meteorite dust almost atom by atom, hoping to find a very specific catch.
And what are they fishing for? They're on the hunt for a presolar grain that has the unmistakable chemical fingerprint of a Wolf-Rayet star. If they can find one of those grains, and if it's loaded with that telltale aluminum-26, that would be a huge, huge victory for this new theory. It would be the strongest evidence yet that we were born in a bubble, not from a bang.
But right now, this is still a very active debate. The case is not closed. The final answer to our own cosmic origin story is still locked away inside these impossibly tiny, incredibly ancient pieces of stardust, just waiting for someone to find it.
It really makes you wonder, doesn't it, if the answer to where our entire solar system came from is hiding in a piece of dust smaller than a living cell. What other universe-changing secrets are just sitting out there, waiting for us to ask the right questions?